Hey guys, today we'll be learning about naming acids. To start, we're going to learn the basics, which is naming acids with simple anions. There are 3 steps and rules that we need to go over before we start. The first step is that this name of the simple anion and acid is that it's always going to start with the prefix hydro. The second step is that any of the anions within the name, the ending of the anion changes to ic. So fluorine becomes fluoric, chlorine becomes chloric, bromine becomes bromic, and so on. The third rule and step is that at the end of the name there's always acid. So we can start with our first example here. We have fluorine, which will become fluoric. I could have just typed this, but we'll just write it out. And we're also going to add our hydrogen to it. So now we have HF. This is balanced. Hydrogen is +1, fluorine is -1. Now, we know that the beginning is going to be hydro, followed by fluoric, hydrofluoric, because fluorine becomes fluoric, and then followed by acid because it's an acid. Pretty simple. Simple anions are pretty simple, but from here it progresses and gets harder. Let's do one more example. So we're going to use chlorine, and we can do chlorine, which becomes chloric, and we have our hydrogen with it now. This is also -1, so this is balanced, so we don't need to do anything. So we have hydro, which is the prefix before all of these names, and then we have chloric because the chlorine becomes chloric, followed by acid, which is always at the end. Naming simple anions is pretty easy, and from here we'll learn about naming acids with polyatomic ions, which gets a little bit harder, but it's not too hard.
Alright guys, next step is teaching you guys about naming acids with polyatomic ions. To start, we'll use a chart on the left to figure out the initial name of the polyatomic ion. There's 2 rules to figuring out the ending for the ions. First rule is any ion ending with 8 becomes ic. For example, perchlorate becomes perchloric. You just change the ending of 8 to ic. And a helpful way to remember this is following the mnemonic device. I ate an acid and it was icky. The second rule is figuring out the ending for a polyatomic ion when ion has the ending of "ite." You change the "ite" to "us," O-U-S. For example, you change nitrite to nitrous. This becomes "us." And a helpful way to remember this is use the mnemonic device. I only bite into things that are delicious. And remember that you should always add the word acid after it. An example being carbonic acid. We know carbonic ends with IC, so we know it comes from carbonate right here. An example of this is carbonic acid. We know the ending is IC, so we know it comes from carbonate. The equation is CO3 -2. We have to add H in front of it because this is an acid. But since there's the charge is -2, you have to have 2 hydrogens. So it's like this. This balances out the whole equation.
The last thing that we'll be teaching today is trying to figure out the equations, giving the names. So we're given the name chlorous acid, so let's just write that out real quick. Chlorous acid. Now what do we do from here? Well, we know that acid is always at the end, so it doesn't really affect our equation at all. So we can just look to our chlorous here. Now we know that OUS comes from ITE, so we just replace that OUS with ITE, and that gives us chlorite. Now we know that's not a anion on the periodic table, so we go to our polyatomic ion and that chart, and that gives us chlorite. And we know that equation is ClO2 -1. Now, when you add the hydrogen at the front, because it's an acid, it's balanced already. Hydrogen has a charge of +1 and chlorite has a charge of -1. This was easy. Let's go on to a harder one now. So erase these real quick. Okay. Next, we're given the name carbonic acid. Carbonic acid. Again, the acid, don't really need to look at it to figure out our equation here, so we can just look to a carbonic here. Now we know that IC comes from ATE, so this is carbonate. Now that's not on the periodic table, so let's go to our polyatomic ion chart. And carbonate is right over here, and has equation of CO3 and -2. Now we have our hydrogen, because it's an acid, but the problem this time is that hydrogen has a charge of +1 and this has a charge of -2, so we need 2 hydrogens to balance it out. And that is how we figure out the equation given the name.